Hello, welcome back to my class. I am Madam Sania. So today we are starting a new topic. It's called network analysis. So network analysis, this is a system between jobs and tasks for planning and control of resources of a project by identifying a critical path. So in a nutshell, you can say network analysis is used in cases where you have limited resources or you have limited workers or laborers. This is when you use network analysis, because you're going to analyze the whole project and see the shortest time you can take to achieve your objective. So there are important terms that you need to know when it comes to network analysis. One is activity. When you see the word activity, this is a task or job of work which takes time and resources. So this is what we call an activity. So when you come across a question, you see the word activity, what should come to mind is that an activity is a task. And then it's denoted by this line. This line here with an arrow. That's how you denote an activity. An event is also known as a node, and this is a point in time and it shows the start or finish of an activity. So an event is denoted by this circle, and it shows the start or finish of an activity. Okay? And then a dummy activity, this is an activity that doesn't consume time or resources. So mainly a dummy activity is used for logical purposes. You will see this when you come to the rules of network analysis, because there's some time you have to bring the logicality in the network, so you will have to use a dummy activity. And a dummy activity does not use any resources, it does not use any time, and it's denoted by this broken arrow. Okay? So the other part is the network itself. So a network is a combination of activities and events. Now when you take these activities, we said the arrows is what we call activities, and this is the node and the dummy activity. Now the combination of all this is what we call a network. And what we're looking at is the analysis of a network. Now we're going to analyze this network. So when it comes to network analysis, there are rules. There are rules in drawing this network. There are rules you must follow in drawing these networks. And this is important for you to know. One of the rules is a network has one start point and one finish point. So a start point is when the first event is, and a finish point is where the last event is. It has only one start and one finish. You cannot have two starts or two finishes, no. It has to be one start point and one finish point. The second rule is all activities must have a tail and a head event. We say this is an activity. So you cannot have a hanging activity. It must have a tail event and it must have a head event. Tail is what is behind it. Head is what is in front of it. Sometimes you can see the words preceding. When you see the words preceding and succeeding. When you see the word preceding event, it means the tail event. When you see the word succeeding event, it means the head event. Okay? The other rule is an activity can start after tail event is reached. So an activity can only start after you reach the tail event. So, and then the other one is an event is complete after all activities leading to it are complete. This is also another rule. The other rule is activities are identified by alphabetic or numeric codes. So this activity, this alphabetic, you can either call it A, B, C, D, or numeric, you can call it 1, 2, 3, 4. That is what it means by alphabetic or numeric codes. And then 5, loops and danglers are not allowed. Loops are basically this is a loop because this leads to this, this leads to this, this leads to this, and the whole process continues. That is what we call a loop. Danglers are now the hanging events. Danglers, they are dangling, they are hanging. These are not allowed when it comes to network analysis. If you draw a network and you see you have danglers or you have any loop, just know you're not on the right path. So we come here to time analysis. Now this time analysis, first you should draw the network. And we say the network is a combination of events and activities. You draw the network, and then you insert the time estimates. So take for example, you've drawn your network. When you take a look here, this is our start event, this is our end event, and we don't have any loops, we don't have any danglers. So after you draw your network, you should put the time estimates. Maybe so you can say maybe it takes you 4 days to move from this event to this event. Maybe your event, your whole project is traveling Kenya. You can take that for an example. Your whole project is traveling Kenya, so you start by, now the first activity, you tour Taita Taveta. Your next activity is you tour maybe Mombasa, and then your last activity is you tour Kisumu. So you can have, maybe this is your activity A, B, and this is your activity C. So if this is A, this is B, and this is your activity C. So it takes you 4 days to tour Taita Taveta. It takes you 3 days, 2 days. 4, 3, 2. That is basically what it means. You draw your network. Your network now, when you achieve all these activities, you will have achieved your whole project. And then you take the time estimates. Now the time estimates is basically the time taken to achieve that one activity. Okay? So you draw the network, you insert the time estimates, and then in a case where you have multiple time estimates. Now this comes in, you have a question. The question does not give you maybe touring Taita Taveta will take you 4 days. They give you maybe the optimistic time. Optimistic is someone who is positive, someone who is positive. Pessimistic time is like negative time taken, and most likely time. So they give you these 3 time estimates. In a case where they don't tell you touring Taita Taveta will take you 4 days, they give you maybe an optimistic person will tell you touring Taita Taveta will take you 3 days. A pessimistic person will tell you touring Taita Taveta will take you maybe 5 days. And then most likely someone, maybe they'll tell you it will take 2 days. Now you have these 3 time estimates for one activity. You see now, you cannot just say, I'll just go with the optimistic, or I'll go with the pessimistic, or I'll go with the most likely. You should calculate to get an expected time. So this is the formula. You take the optimistic plus the pessimistic plus 4 times the most likely, and then you divide by 6. So in our case here, you take 3 plus 5 plus 4 into 2, and then you divide by 6. The answer you get here is the time you're going to place, is the time you're going to use. Okay? So another thing we're going to look at is the critical path. This gives the shortest time in which the whole project can be completed. Now the critical path, it gives you the shortest time in which the whole project can be completed, because maybe in a project you can have to go through so many activities before you get to the end, or now the shortest time, which is going to be your critical path. And then these 2 formulas are very important to take note of, because you're going to use them. We have the EST. The EST is the earliest start time. The earliest start time, this is the greater of EST tail event and activity duration. You'll see how this applies in an example. And then LST is the latest start time. This is the lowest of LST head event minus activity duration. You will see this in an example as we look at our example. So now we are going to look at an example. So this is our example. We've been told the following represents activities of a network. So this is the activity, this is the preceding activity. We say when you see the word preceding, it means before. It means before, or it can mean tail. So, and this is the duration. So this is the question you've been given. Now you have to draw a network from this question. You have the activity is A. It has no preceding activity. To mean this is the first activity. You have the activity B. The preceding activity is A. To mean B only happens if A has already happened. The same thing, C only happens if A has already happened. D only happens if A has already happened. E happens after B. F happens after C. G happens after E. H happens after B and F. So H comes from the activity B and F. Okay? You'll see all that when you come to draw the network. So first things first, we said you should have one start point. So this is our first start point. This is our first event. From the event, our first activity is A. We said an activity is denoted by this arrow. So you draw the arrow and then you have your A. And then B, activity B happens after A. Now A has already happened. You should have an event here. Sawa? And then activity B happens. Now this is our second activity B. Okay, here. And then also C and D stem from A. So you have C here, and then you have D here, like that. Are we together? And then E happens after B. Now our B has already, this is activity B. So you should have an event. Remember, every activity should have a tail event and a head event. So after activity B, this is the tail event for activity B. This is the head event for activity B. So E is going now to stem from that. To mean B happens and then E. Okay? And then you have F stems from C. Now you go to C, your activity C. You put the event, the head event, and then F. Okay? After F, we have G. G comes from E. Now you go back here, where you had your activity E. You draw the head event, and then you go to activity G. And then H stems from B and F. Now, where is our activity B? H stems from B and F. Yes, now we have activity B here, and you have activity F here. And H should come from B and F. Now this is where you're going to use the dummy. You're going to use the dummy activity. When we say the dummy activity is used for logical purposes. So our logical purpose here is because this is activity B is on this side. Activity F is on this side. And for H to happen, B and F have to meet in the same event. So for them to meet in the same event, there's no way you cannot put activity F to come like this. You cannot say F here, because it would mean E stems from B and F, which is not true. So you have to draw the dummy activity to show B has come here so that H can happen. So this is B and this is F, and then activity H happens. Okay? And then the other activity I, it stems from G and H. So we had our G and H, they're all going to end at the same event. So G and H, they end at the same event, and then activity I happens. Okay? And then J happens from C. So from activity C, you have J, and then from activity K, you have D. From activity D, you have K. So this is activity D, and then K. And then L, activity L, which is our last activity, only happens after I, J, and K. So when you're drawing your activities, you make sure that I, J, and K, they meet in the same node. So when they meet in this node, and then L is going to happen. And L, since L is our last activity, now we also have the last node. So you see our rules for drawing a network. We have one start, we have one finish. If you look at it, do you have any loops? You don't have any loops. Do you have any danglers? You don't have any danglers. Every activity has a tail event and a head event, yes? So that is how you're going to draw your network before you even start filling in these numbers. As of now, just ignore whatever is in the circles. Just take note of how the network looks like. Okay? Now from here, you're supposed to calculate our critical path. And for you to calculate the critical path, you should first calculate your EST and your LST. So first, before you even calculate LST, you have to start with EST. And EST is the greater of tail event plus activity duration. Now when it comes to EST, you have to start with the start event. So this is our start event. We're going to start with our start event, and then in the start event, you're going to give it the number 0. That is how you start calculating EST. So when you have an event like this, on this side you write the EST, and then on this side you write the LST. So as of now, when you're doing EST, ignore whatever is in the second part of the line. Ignore that. Just take note of what is on this side. Take note of what is on this side, because that is our EST. That is how we are going to calculate it. So as I've told you, when you're calculating EST, the first things first, from the start point, the EST is 0. Okay? So now we have our EST as 0. Now we want to go to this one. We want to calculate the EST for this other node. And we're told the formula is the EST tail event plus activity duration. So we are here. This is where we are standing. We want to calculate this EST. And you're told it's the EST tail event. So the EST tail event is 0 plus activity duration. Activity duration is this 4. So 0 plus 4 is 4. That is why we have 4 here. Okay? So you go to your next one. You can go here. This is where you're standing. You want to calculate the EST. The EST, now when you're in this node, the tail event changes. It does not become this. The tail event is going to be this. So EST tail event is 4 plus activity duration. So here we have 4 plus activity duration, which is 7, to give you 11. That is how you're going to calculate it. When you're here, when you're standing here, EST tail event is 4 plus the activity duration is 5. 4 plus 5, you get 9. When you're calculating EST for this, EST tail event is 4 plus activity duration, which is 6. 4 plus 6, it is 10. So you're going to do this for all nodes until you get to the last one. But there's a catch. You see there's something here that says the greater of the EST tail event plus activity duration. This comes in a case where, when you're calculating for here, you'll take 11 plus 2, which is 13. Now when it comes to this, when you're standing here, when you want to calculate the EST for the number 8, you see when you look at it, how many tail events does it have? It has this tail event, and it also has this tail event. Okay, so now here it has 2 tail events. So what do? You calculate for each side. When the tail event is this, it's 12 plus 11, which is 22. And when the tail event is this, it's 13 plus 5. This is 23, sorry. 13 plus 5, which is 18. And the formula for EST tells you, you take the greater. So when you compare 18 and 23, which is greater? 23. That is why here we have 23 and not 18. Okay? The same thing happens when you're standing here. Because how many tail events does this node have? It has 1, it has 2, and it has 3. All those are tail events. So you calculate for all 3, and then you look at which is the greater. So when you're calculating, as this is the tail event, this here will be 10 plus 3, which is 13. When this is the tail event, it's 9 plus 4, which is 13. And when this is the tail event, it's 23 plus 7, which is 30. So when you compare 30, 13, and 13, which one is greater? 30. That is why our EST here is going to be 30, because EST you're told to take the greater. So for the last one, it's going to be 30 plus 4, which is 34. That is how you're going to calculate your EST. Now after calculating your EST for all the nodes, you come to calculating the LST. So when it comes to calculating the LST, you say LST is now whatever is in the other half of the circle. when you're calculating LST, the formula says the lowest of LST head event minus activity duration. So remember when you're doing EST, we started from the start point, we went all the way to the last point. Now when you're calculating LST, you work backwards. You start from the last point, you work all the way to the starting point. So LST, now how do you know the first LST? We knew the first EST because we said EST every time from the start point it's 0. But now when you're calculating LST, you see this answer that you get as your EST in the last point, you're going to duplicate it as your LST. That is where you start from, okay? So we got our last EST as 34, so our LST starting point is going to be 34. So we are working backwards. And we are taking LST head event minus activity duration. So when you're standing here, which is the head event? We said head is whatever is in front. Head event is this. When you're standing here, our head event is this. Yes? So we take LST, this event it is 34, minus activity duration. 34 minus 4, you get 30. Okay? When you're standing here, your head event is which one? Your head event is this. Your LST for this head event is what? It's 30. So you take 30 minus 3, 27. Okay? When you're standing here, how many head events does this event have? It has 1, 2, 3. So you cannot calculate for this until you have LST for this and LST for this. So we go to another one. So we can only move here. Now when you're standing here, our head event is only one. This one. LST head event is 30 minus 7. You get 23. So when you're standing here, our head event, how many head events does it have? It has only one head event. So it's 23 minus 11, you get 12. And then when you're standing here, how many head events does this event have? It has 1, it has 2. It has 2 head events. So you calculate for 30 minus 4, 21, and then 12 minus 3 is 9. So, and our formula says you take the lowest. It's different from EST. EST you are taking the greater one. Now for LST you take the lowest. When you compare 9 and 21, which one is lower? It's 9. That is why our LST here is 9. Are we together? And then for here, when you're standing here, you take 23 minus 5, which is 18. And then when you're here, you take 18 minus 2, which is 16. Now you can calculate for this. Because this, it has 1, 2, 3 head events. So it's 16 minus 7, which is 9. 9 minus 5, which is 4. 27 minus 6, which is 21. Now you have 3 options, but you're supposed to take the lowest. You have 21, you have 4, you have 9. And the lowest is 4. So that's why you have 4. So for the last one, it's 4 minus 4, you get 0. That is how you calculate your EST and LST. Now, we say you cannot get your critical path unless you've calculated EST and LST. Now that you've already calculated what EST is and what LST is, how do we know your critical path? The areas where the EST is equal to the LST, it gives you the critical path. So you have here 0, 0, 4, 4, 9, 9, 12, 12, 23, 23, 30, 30, and 34, 34. So that is going to be our critical path. So when you want to show your critical path, you can either use a different color to show the path, or you can use these 2 lines here, these 2. So we said where the EST and LST are equal. So it's here, 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 and here. That is how you're going to show your critical path. So your critical path is A, C, F, H, I, and then L. when you want to calculate the project duration, you add the duration in this critical path. You add the duration here for A, which is 4, for C it's 5, for F it is 3, for H it is 11, for I it is 7, and for L it is 4. So you add and you get your answer as 34 days. So that is how you calculate your critical path. When it comes to network, it's very important you take note of how you calculate EST, LST, critical path, and project duration. And you cannot calculate these two unless you know what your EST is and your LST is. And you cannot calculate LST unless you know what your EST is. So that is how you're going to be able to solve this network. So we come to the end of our class. See you in our next topic.